Hey guys, these notes are for graphing linear transformations. We also do writing transformations, but that'll be the next set of notes. Our essential question is, how can patterns forecast the future? All right, so we're going to begin talking about our first type of transformations, which is translations. We're going to see translations, reflections, and dilations. And these are all kind of words that you should have heard of in middle school, especially like when you guys were talking about shapes. So a translation is basically moving something up, down, to the left, or to the right, okay? Your slope does not change. It does not change, okay? So all you're basically doing is you're shifting things. Like when you guys had a triangle in middle school, they shifted it down, and it would still be the same triangle. The shape didn't change. All that changed was where it was located, okay? So these are the four types of translations we will see. So the first one we have is f of x plus d, which means it's going to be going up, okay? And then g of x equals f of x minus d means we're going down. So really, I'm only caring about this part right here. It's all going to be in function notation, so you're going to be given a function f of x. So let's say they give you f of x equals 3x minus 2. Let's say they give you that function. And remember, f of x is just y. But when we're talking about multiple functions, we need to use function notation. So let's say like this was your original function. The g of x is telling you the transformation that's happening. So it's taking that original function, your f of x, and then moving it up or down, okay? And then the next types of transformations we'll see, or translations we'll see, is the minus c and the plus c inside the parentheses. These are inside. So it's actually going to be the opposite of what you would think. So you're thinking either left or right, and you're probably thinking minus c is going to the left, but it's actually going to go to the right. Okay? Now the way you want to think about this is that your parentheses are like a house, okay? So in the first two, these two guys up here with the d's, plus d and minus d, those are outside of your parentheses, right? They're outside of the parentheses. Whereas the second two, minus c and plus c, are inside the parentheses. So think of it like a house, okay? You're trapped in your house with your ex, right? This is your ex. Like your ex-boyfriend, ex-girlfriend, whoever. You're trapped in the house with them, so they're gonna tell you what to do. So they're like minus c. Oh, then go to the left. Well, you're not gonna go to the left, you're gonna go to the right. So you're doing the opposite of what your ex is telling you to do and what your ex is wanting you to do. So it's like wanting you to go to the left, but you really wanna go to the right. So that means if I have plus c, you're gonna go to the, oh geez. If you have plus c, it's gonna go to the left, okay? So those are kind of opposites. So those are gonna be the tricky ones to remember. Now, in the first two with up and down, those are outside of the parentheses. So you're outside of the house, your x is not there, so you're going to do what you think you're going to do. Plus d is going to be up, minus d is going to be down. So here's some examples. So if we have f of x plus 5, that 5 is on the outside of the parentheses, so that means I'm going to go up 5. Okay? If I have f of x minus 3, that's outside of the parentheses again, so that's going to be down 3. All right? Now I have f of x minus 4, and that minus 4 is inside my parentheses. So I'm in the house with my x. So you're thinking, oh, left 4, but you're wanting to go to the right 4. Okay? And then f of x plus 2, you're going to go to the left 2. Okay? So that's our translations. Now we're going to graph them. So we're going to use the parent function to perform the following translations. So let's review our parent function of the linear function. Remember, that's y equals x, okay? Or we're using function notation here. So it's going to be f of x equals x. So we're not going to use y, we're going to use x now. So we have f of x equals x. And remember, that's just y equals x. So let's identify what our slope is here. Our slope is the number in front of our x, which is just 1, so 1 over 1. And then my y-intercept here is 0, because it doesn't have a b value. So you're going to want to graph your parent function first. So I'm going to graph the point 0 for my y-intercept and go up 1 over 1, up 1 over 1. And I'm just going to do 5 points for the sake of trying to like explain this better to you. So I'm just going to create 5 points on my graph. Normally I ask for 3, but I'm going to have 5. I'm also going to use the parent function for number 2, so I'm going to go ahead and graph it on this one as well. All right. Okay. Now, We're graphing the original parent function, and then we also have to graph the transformation of that translation. So you want to label your line. So you want to make sure that that orange line is clearly marked, that I know that this is the f of x. This is the original function. Whereas my transformation function is going to be my g of x. So I'm going to graph the g of x in pink. Well, I need to figure out what that first means. So I have f of x minus 4 here. And remember, I only really care about like what it's telling me in the back end. It's always going to have a g of x, f of x, like there's always going to be two functions in there, but you really want to look at the transformation. It's saying minus 4, and so it's going to be down 4 because it's outside the parentheses. So the g of x is going to be your new function, means that you're going to take the old one, which is your f of x, and you're going to go down 4. Okay, so you see all those points that we plotted? Well, you're going to take all those points and then move them down 4 extra points. So I'm going to start at this one right here. I'm going to go down 1, 2, 3, 4, and I'm going to bring that point down. Just straight down, completely straight down, just go down 4 units. And then you're going to do the same thing with the next point. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so all you did was you shifted every single point down 4 units. Okay, that's all we're wanting here. And then we also want to label that. So you do have to label that on your homework and on your quizzes and on your tests. You need to be able to label both of your lines. So your orange one is your original and the pink one is the new one. Okay, moving on, we have g of x equals f of x plus 3. So again, I already graphed my original line, but now I need to translate what that means. So the g of x is going to be my new function. Okay, it's telling me that I'm going to take my old one, my old function, my f of x, and then there's an x plus 3 in the inside of my parentheses. So I'm in the house with my x. You're wanting to think I'm going to go to the right 3, but you're wanting to do the opposite. So you're going to go to the left 3. Okay, so you're going to take your old function and move everything to the left 3 so that you can have your new function. So I'm going to start at this point right here, and I'm going to go to the left. So I have 1, 2, 3. And again, you go straight over. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so you're taking all 5 of your points that we graphed earlier, and we just shifted over to the left. Okay, that's what a translation is. Nothing changed. The slope didn't change. We're just shifting it over. And remember, we always want to label our lines. So you always want to clearly label so I know. You don't want to mix them up. So that's translations for you. The next one we're going to do is reflections. That's the second type of transformation we'll see. And a reflection is basically a flip of the function over the x-axis or y-axis. Okay, so in Algebra 1, you're only going to see it flip over the x-axis or y-axis. When you get to Algebra 2, you'll see a little bit more. But this basically, your reflection is acting like a mirror. It's going to be like a mirror image of itself just flipped over. Okay, so now we are going to talk about the 2 types of reflection that we see. So the first type is going to be g of x equals negative f of x, and then g of x equals f of negative x. So notice the difference between these two. The negative is on the outside here, and it's on the inside in here. Okay? So let's talk about the differences between the two. The first one is going to reflect across the x-axis. Okay? So it's going to flip over on the x-axis. Now I want you to say reflect if you have to say reflect. We don't really want to use the word flip too much. We want to use proper math vocabulary. So make sure we say reflect. And then so if that one's the x-axis, then the next one's going to be a reflection across the, whoops, that's not spelled across the y-axis. Okay? So just make sure that you understand the difference between these two because you don't want to do the opposite, okay? It's hard to give you partial credit if you don't do anything close to what it was asking for. All right, so we're going to go ahead and graph some reflections. So we're going to use the function f of x equals 1/2 x minus 2 to perform the following reflections. The first set of transformations we saw were translations, and we used the parent function, so it was f of x equals x. But now they're giving us like a real function, like a different function. So we need to graph this on both of our graphs here. We have to use it for both. So our slope here is 1/2, and our y-intercept is going to be 0, -2. So you always want to start off at your point. So I'm going to graph 0, -2, and then I'm going to use my slope to graph the rest of the line. So I'm going to go rise 1, and then to the right 2, rise 1, up 2, rise 1, up 2. I'm going to graph 4 points on this one just because. Okay, and then I do want to label that, so that's my f of x function, my original one. So we learned how to graph linear functions in the last unit, so this should not be a surprise to you. Okay, and then I'm going to do the same thing here. I'm starting at -2 for my y-intercept, and I'm going up 1 over 2, up 1 over 2, up 1 over 2. All right. Okay, so I have my 2 lines there. Again, make sure you label them. You'll get points off if you do not. All right, and so let's talk about this first one. So g of x is just saying, okay, my new function. So the new function is going to be my old function, and there's a negative on the inside. So the negative on the inside tells me I'm going to reflect across the y-axis. So I'm going to take my old and reflect it across the y-axis. Okay, the y-axis. So basically, I'm going to highlight my y-axis. Whoops, my iPad froze. Give me 1 second. I need to reset it. There we go. Okay, I'm going to highlight y-axis again. I'm going to highlight my y-axis because I do want to look at that as my reflection point. So I'm going to highlight that, and I'm actually going to do a different color. I'm tired of orange. Let's do blue. There we go. Okay, so again, with your points, you're going to reflect them. So let's start with this point right here. Well, on the y-axis, if I reflect it, it's just going to stay in the same place. Now, this point over here, I need to reflect it to the other side. So it is 2 away. So we have 2 away from the y-axis, so it's going to be 2 away on the other side as well. Okay? Whoops, that's not what I meant to do. Okay, I just don't know how to work my notability, apparently. Okay, so you always want to make sure that it's the same distance away. And I'll even help you out. I'll draw some little arrows or something. So this is going to be the same distance away from your y-axis. And then your next point here, this one's 4 away from the y-axis. So I need to make sure that it's 4 away on the other side too. 1, 2, 3, 4, right? You want to make sure that your length is the same amount on both sides. You do not have to draw those blue arrows if you do not want to. That is clearly up to you. And then the last one we're going to do, this one's 1, 2, 3, 4, 5, 6 away. So let's see, 1, 2, 3, 4, 5, 6. So it's going to be a point right there. So my new line, I need to redraw this one because I don't know what's going on. Boop. Okay. So my transformed line is this guy right here. And every point that I have is the same distance from the y-axis on the other side. So they're kind of like little mirror images of each other. Do you see that? It's the same point across on each one. All right. You're just flipping it over the y-axis. Okay. Now the next one, we're going to take our new function, and we're going to take the old, or not take our new function. We're taking our old function, and we're reflecting it across the x-axis. Okay, so I'm going to highlight my x-axis this time, and I'm going to start graphing my new function. Let's do pink. Now my new function, oh, you want to know what I forgot? I forgot to label the last one. Make sure you label, because I just forgot to. Alright, so this one's reflecting across the x-axis, so same process, and I'm actually going to add some more points onto my green one, so down 1 over 2, just so that we can see what's going on. Whoops. Exactly. So this is my line. Okay. And I'm going to take every single point and reflect it across the x-axis this time. So now we're flipping it to the other side. I'm going to start at this point here. It's 1 away from your x-axis, so it's going to be right here, 1 away from your x-axis. This one's on the x-axis, so this one's going to stay. And now we're on the other side of the x-axis. We're over here now, and I'm going to flip it to the other side. That's also 1 away. And then we're going to take this point, the next one, and flip it, and that one's 2 points away. So it's going to be over here, 3 points away, so right there. And then this one is 4 points away, so I'm going to go right there. Oh wait, I think I messed up. Hold on. I can't count apparently. Okay, yeah, this is 4 points away. So it's like that. And if you're having trouble kind of visualizing this through the video, I can definitely help you like before or after school. It's kind of hard to explain without me like showing you with my hands and stuff. But you're just flipping it or reflecting it across whatever axis it tells you by the negative sign. The negative sign indicates to me that I have a reflection, okay? So if it's negative, I'm going to have a reflection. You just have to figure out which one. All right, and the last type of transformation we see are dilations. And I think you guys talk about dilations in either 7th or 8th grade, I believe. But a dilation is our first vocabulary word in this, and the only one really, is a stretch or a shrink of a line. And this is kind of hard to like explain. You see it a little bit better with quadratics, and we will talk about quadratic transformations in unit, I think, 7, but right now it's going to be kind of hard to see with a line. But I do want to mention that there's 2 important things about dilations, that sometimes it changes your slope, and sometimes it changes the y-intercept, okay? Your y-intercept is not always going to change, but it will change the slope usually, okay? Actually, I don't know why I said sometimes. It does change the slope, so I don't know why I said sometimes. It does change it. Okay, and so there's 2 types of dilations that we will see. So notice in the first one we have a letter on the outside, which is A, and on the second one we have a letter on the inside. So the important thing to know, let's talk about the difference, right? Here's the important thing. Where is the A located? It's located on the outside, and the B is located on the inside. So let's look at the second one first. That B is being multiplied to what? Just your x. So it's only affecting one thing. So for this second one, it's only going to multiply, so only multiplies the slope by B. And B is just a number, okay? Just like C and D, they're just a number. Now, this first one, where A is on the outside, it's going to multiply the slope and also the y-intercept. So it's going to change both things. So this one multiplies both the slope and y-intercept by A. Again, A and B are just numbers. A, let's make a note on the side. A and B are numbers, okay? So let's talk about some examples here. So we have f of 3x. So the 3 is on the inside, so it's only going to affect my slope. So this one's going to multiply the slope by 3, okay? Now the next one, we have 2f of x, and that 2 is on the outside, so it's going to multiply both things. So it's going to multiply the slope and y-intercept by 2. So it multiplies both things, okay? The next one, we have f of 1/2 x, and so that 1/2 is on the inside of my parentheses, so it's only going to multiply the slope by 1/2. Okay, and then the last one, we have 1/4 f of x, and that's going to multiply everything because it's on the outside, so it's affecting the entire function. So it's going to multiply the slope and y-intercept by 1/4. And so I don't know if you've noticed, but everything that we've talked about has been in slope-intercept form and y equals mx plus b form. So that's why we always want that form for when we're graphing for these types of functions. They'll normally give it to you in y equals mx plus b form, slope-intercept, because you do need to know the slope and you do need to know the y-intercept. All right, moving on. We have only 2 graphs left, and then we have the pre-AP section, so if you're not in pre-AP, you do not have to watch that. But we're going to use the function f of x. Oh my gosh, I made a typo. Ugh, I made these notes really late, so I think I forgot. This should be f of x equals 2x plus 1. My bad. Okay, use the function f of x equals 2x plus 1 to perform the following dilations. So I do need to graph f of x plus 1 on both. My slope here is going to be 2, and if I want to actually use it as rise over run, I need to write 2 as a fraction. So it's going to be slope is 2 over 1. And my y-intercept is going to be 1, which is 0, 1. So I'm going to graph those on both lines. I have a positive 1 for my y-intercept, and then I have a rise of 2, and then I have to go to the right one. Up 2 over 1. And then I'm actually going to go down 2 over 1 just because. Okay, so I have a pink line here, and that's my f of x function. And I'm going to do the same thing for the next one. Okay, make sure you label. All right, now let's look at what this is telling us here. So we have g of x equals 2f of x. So the number is located on the outside. So let's go see what happens when it's on the outside. So it's going to be the first one in green. If that's on the outside, it's going to multiply both my slope and my y-intercept. So I need to go back. Okay, so it's going to take, so f of x is what? F of x is this up here. So it's going to be 2x plus 1, and I need to multiply the whole thing by 2. Okay, so I need to multiply both the slope and the y-intercept by 2. So I have g of x equals, so all we're doing is substituting what f of x is, and we know f of x, it's 2x plus 1. And so we have g of x equals 2 times 2x, which is 4x, and 2 times 1, which is plus 2. So now we have a new graph. So basically, just graph this new line. What's my slope? 4 over 1. What's my y-intercept? 2. So I'm going to plot the point, positive 2, and I'm going to use my slope of up 4 over 1. 1, 2, 3, 4. 1, and then I'm going to use the other slope, which is down 4 over negative 1. 1, 2, 3, 4, and then go that way. Okay, and I think I can go down one more. 1, 2, 3, 4 over 1. So my new line looks like that. So that's going to be my g of x function. Okay, so make sure you label both lines. But that's all you're doing. You just need to check to see what you're multiplying by. And then the last one, we have g of x equals f of 1/2 x. Now that number is on the inside, so it's only going to multiply my slope by 1/2. Okay, so multiply just the slope. Only, I don't know why my L is capitalized, only the slope by 1/2. Okay, so my original function, I have f of x equals 2x plus 1. So in my new function, my g of x, I'm trying to decide on what color I want. G of x, I'm going to multiply the slope by 1/2. So what's our slope here? 2. So what's 2 times 1/2? That's going to give me 1, so I just have 1x. And then I'm going to keep the y-intercept the same, so that doesn't change. The only thing that changed was my slope. And so my new slope is going to be 1 over 1, and my y-intercept is still going to be 1. So I'm still going to have a point there at positive 1, and then I'm going to use my slope 1 over 1 to graph the rest of my line. Okay? And then I'm also going to label that my g of x. But that is it for our transformations. We just have 3. We have translations, reflections, and dilations. The only hard thing about these is just remembering what to do, because the graphing part is easy as long as you know what to do. So just make sure that you're able to get down all of the transformations. If it helps, I'm going to go ahead and write like a master list down here. So we're going to have, we have f of x plus d, f of x minus d, f of x minus c, f of x plus c. We have we have negative f of x, we have f of negative x, and then we have a f of x and f of bx. So we have, let's see how many that is. That's 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 transformations, but these 4 are pretty easy. And then these 2, you just have to, those 2 are probably the hardest to remember. You just have to remember the rules on those. But we have 8 transformations that we learned, and I'm actually going to cut the video so that Preap can watch a separate video.